Welcome back. So far we have been talking about how two heterogeneous information system can communicate and what are various ways to make them interoperable. This we were talking in the context of integrating the supply chain. A new way of integrating the supply chain is through cloud infrastructure, where many companies can be communicating with each other or taking advantage. It is not that always they will be using it for communicating, but they can actually decrease their own infrastructure cost and will be able to use many advanced systems by using these cloud based models. So, in this lecture we are going to learn what is cloud computing, what are the basic characteristics of it, various service models, deployment models and advantages and disadvantages of using cloud. Now, this cloud computing is the delivery of computing as a service rather than a product, whereby shared computing resources, software, information are provided to computers and other devices over the network. So, this is basically a shared pool of configurable computing resources and you can access those resources over the network on demand and they are provided by certain service provider. These are basic characteristics of a cloud based system. It is remotely hosted, both the service and data are in remote locations, it is in a remote infrastructure. It is ubiquitous, even if it is kept in a remote place which you possibly do not know, in some data center it is lying, it is available to you from anywhere if you are connected to the internet. Then the next thing is the fact that you will be using it on a pay per use mode. If you use it, pay it, if you do not use it, do not pay for it. So, it is now commodified. This is based on the resource pooling. By resource pooling we mean we have multiple number of resources handled together, so that and used by several entities, so that the resource is not lost. Computing resource is very precious and many times we do not utilize full potential of the resource. So, whenever somebody is not utilizing the resource and it is somebody else is allowed to use that resource, then the resource might be fully utilized. So, it is based on the concept of resource pooling. Then it has rapid elasticity, which means today suppose you require some 1 GB of storage over the cloud, next moment your 1 GB is over and next moment you want another GB. Unlike your physical world, when you have to buy maybe possibly another GB memory, here it will be given to you immediately because it is available in a pool. Then it is because it is commodified, it has been used as a commodity, it can be measured and it can be monitored, it can be metered, and it may be up to some extent can be controlled and optimized, so that many people are able to use it and pay for it, so that the person who is maintaining that infrastructure can charge small amount from individual, yet will be able to make the profit. There are many cloud services model. These are three basic models: infrastructure as a service, platform as a service, and software as a service. When it comes to infrastructure as a service, it is a cloud offering in which a vendor provides users access to the computing resources. How much memory, how much storage, how many servers. You have a large computing system. Let us say there are 100 processors available. To one person you give, let us say 5 GB memory, some 12 processors, and so on, out of your whole available resources. So, this model is called infrastructure as a service. Now, the vendor provides, and the amount of resource you consume depends on the kind of application right now you are running. And as you add more resources and as you keep using these resources, depending on your usage, you pay. To do so, a layer of virtualization is created, which not physically, but virtually divides the entire resource among a number of requesters, a number of clients who request to consume the service. So, these are the key features. So, instead of purchasing the hardware outright, the user pay for infrastructure as a service on demand. Infrastructure is scalable depending on the processing and storage need. It saves enterprises cost of buying and maintaining their own hardware. Now, because the data is on the cloud, there is no single point failure. So, the bottleneck analysis of the individual company's e-business infrastructure, which of course, we will be talking after some time, is not required here. So, next model is platform as a service. When you use your system, hardware is one part, but you above the hardware you use some kind of operating system or some system level software which helps you to use the computing hardware. There are certain cloud services which provide not only the infrastructure, but the platform above the infrastructure to be used by the clients. So, the platform as a service is a cloud computing offering that provides the user a cloud as a environment in which they can develop, manage and deliver applications. So, in addition to storage and computing devices, the user is able to use a suite of pre-built tools to develop their own application. So, which means you will have one operating system, above that operating system maybe some compiler is loaded, using that compiler you develop your own code. Now, service provider offers access to the cloud based environment in which the user can build and deliver applications here. Unlike the other case where only the bare hardware is provided to you, then depending on your requirement you load your own operating system and allied system level software. So, here the provider supplies the underlying infrastructure. The key features: it provides a platform with tools to test, develop and host applications in the same environment. It enables organizations to focus on development without having to worry about the underlying infrastructure. Again, it provides the person, the organization who is providing this platform is responsible for its security, for its updated software, etc. And they also take the responsibility to back up your data. Such infrastructure facilitate collaborative work even if the teams work remotely. Maybe they will be sharing some document which all of us are acquainted with, a Google Doc can be, they can share and individually they can write. Then software as a service. Here the software as a service is a cloud computing offering that provides user with the access to a vendor's cloud based software. By software here we mean then application level software. Let us say you are using certain data mining software which runs over the operating system. So, in this model you will have the hardware, you will have the operating system above that hardware. Additionally, you will have a application level software to run over it. In fact, while discussing about enterprise resource planning ERP, I told you that there are cloud based versions are available. Here the provider delivers the software and applications through the internet. The user subscribe to the software and access it via the web or vendor's API. These are the key features. SaaS vendors provide users with software and applications on subscription model. User do not have to manage, install, upgrade software. This SaaS model provider manages this. Data is secure in the cloud. Equipment failures does not result the loss of data. Now, use of resources can be scaled depending on the service need. The applications are accessible from almost any internet connect device from virtually anywhere in the world. So, if we look at this, at the lowest level is your infrastructure as a service, where you get the storage, computing resource, etc. with certain rent. Your Amazon Web Services is one example of this. Next layer, you have your infrastructure, shared infrastructure as well as some cloud platform hosted on this. Your example of your Windows Azure or your Google App Engine are run at using this particular mode. Next level is your software as a service, where you have the underlying hardware above which some operating system like stuff run, then you have the software running over it. So, many shared softwares are of this type, with examples include your Salesforce, CRM, Lotus Live, etc. Then how these clouds are deployed and who is responsible for providing this cloud infrastructure. This cloud infrastructure can be private, which means only one organization uses it and it may be managed by that organization or it may be managed by a third party. It may be within the premises of the organization, it may be outside that premises of the organization, but it is the organization who uses this cloud. Then it can be a community cloud. It is a shared infrastructure for a specific community. All of them have invested in this infrastructure together and they use it. So, this community can be a industry consortia, it is the company and its supply chain partners and so on. Again, this can be managed by one of the organization who is taking initiative about this, or it can be provided by the third party. Then you have something called a public cloud, like it is hosted by some some company where anybody can use it. In the first case, only one company has its own cloud. In the second case, a group of companies have their own cloud. In case of a public cloud, it is provided by some company and anybody can use it. Then you can also have hybrid cloud, where it composes of 2 or more clouds and they are bound by some standard or proprietary technology. Now, there are many concerns with this cloud computing. What are these concerns? Now, use of cloud computing means dependence on others, and this could possibly limit the flexibility and innovation in a company. This is a concern. So, what people perceive is that someday the companies like Google, IBM, who are maybe your Amazon, who are trying to pioneer themselves in this cloud technology, they will monopolize the market. They will be the single leader. Now, some other argue that use of supercomputer is a return to the time of mainframe computing. Which means at some point of time people will start using PC, just like in against the mainframe computing, people started using small unit called PCs. So, against these supercomputers, something else is going to happen. It has many security concerns as well. So, it is not clear how safe is the process of outsourcing the data is, and why and where this ownership of data goes. I find my data is safe, it is hosted in, but somebody else might be seeing my data. How I should be very sure about it? Now, there are also issues relating to policy and access, like if your data is stored abroad, whose policy do you adhere to? The country where the data is there or the country where you are there? Now, what happens if suppose you move over to the cloud? Now, what happens? That company is under attack and all your data etc. are gone, because you rely on only one company and he may be targeted by let us say somebody may be a terrorist. All the data center the company maintains is destroyed, can destroy it at one go. Where do you stand then? Then there have been cases of users being locked out of the accounts and losing access to the data, because internet probably has not become matured enough to handle cloud. Now, there are advantages, of course, that is why people are adopting. It lowers the computational cost, which is quite obvious, because you do not need some kind of high priced a high performance machine to carry out job by simply using your own PC, which may not be powerful enough. You access some powerful infrastructure and carry out your work. Your own computing power that you have right now becomes irrelevant then. Then, because some specialists are maintaining this hardware, software, etc., the infrastructure that is given to you, they provide you very high level performance, because you cannot afford that kind of infrastructure, but on a shared basis you can definitely afford. You do not have to buy very expensive software, you can be using in a free manner, almost it is as if it is free. Then you can have instant software updates as new patches or new versions come up. That is because it is maintained in one place and one person is specifically responsible for this. Then it can also improve the document format compatibility. You do not have to really worry about which format you use. The format will be provided by the service provider. You have unlimited, virtually unlimited storage capacity and increased data reliability. You no longer worry that there will be virus attack, etc., and your data will be lost because somebody else is responsible for that. Then documents can be accessed from anywhere. Then latest version of the document will be available to everybody. Group collaborations are easier because you can now share documents and you can carry out the projects easily, where multiple sites are involved and multiple users are involved. Because all of you are using only one platform, the question of device dependence does not arise. All of you are accessing only one cloud based system through one web interface. So, that problem does not arise. Disadvantages are actually troubling users. The first and foremost is the availability of the internet connection. Suppose you keep your everything in a remote server and you go to a place where you do not have internet access. Such number of such places where internet access is not there is slowly decreasing, but there are places where internet access will not be there. So, the cloud computing is virtually impossible if you do not have, and moreover speed also matters. It does not work well with low speed connections. And sometimes the feature you have to be, if you are using a cloud based software, you have to, you can only have the features they are offering. If you want to have more features of your own, you cannot, because you are limited by what they are offering. And if your network and computing devices etc. are slow, then the whole process can become very slow. The security concern we have already discussed, the stored data might not be secure, unauthorized access, you never know about what happens to your data and how the confidentiality of the data is maintained, you simply believe. The stored data can be lost, though the system is very reliable, but as I was telling, there is always a limit to everything. So, it may so happen that there is some damage done to the cloud infrastructure. In that case, everybody who is using that cloud may not be are likely to lose their data. Then it is also not understood that how this computing intensive, this high performance computing applications run over cloud. It is not sure, because HPC is coming in a big way, where you can use parallel computing to carry out very computational intensive jobs. How to emulate it over the cloud is still not clear. Then general concerns like use of different protocols etc., using a specific database system, forced to follow certain standard which your provider is providing, are some of the other concerns. So, with this we finish this lecture and see you in the next lecture. Thank you very much.